Hi, welcome back. The problem today is about inequality, that x and y are real numbers and they are both different from 0. Now, let's get started. We have x squared over y squared plus y squared over x squared plus 4 greater or equal than 3 multiplied by x over y plus y over x. We have to prove this inequality. So, from this inequality, we can easily to see that we can put the substitution by case equal to x over y plus y over x. And this is very familiar from that case. Square minus 2 will be equal to x squared over y squared plus y squared over x squared. That is the famous form we usually apply in every problem which consider the substitution like this. Then we replace this back to the inequality. On the left hand side, this will be k squared minus 2 plus 4. And on the right hand side, it will be 3 multiplied by k. Simplify both sides of the inequality, we will have k minus 3 k plus 2 greater or equal than 0. We have to prove that with any k values. For the left hand side, this will be equal and k minus 1, the factor, multiplied by another factor by k minus 2. Then this is factorized into k minus 1 multiplied by k minus 2. And for now, we have to check the condition of x and y. If x is positive numbers and y is negative numbers, or x is the negative number and y is the positive numbers, then k always greater smaller than 0 because x over y would be smaller than 0 and y over x also smaller than 0. So the sum of two numbers are smaller than 0, then this should be a negative number. The same for the second case. Case also have to be smaller than 0 because x over y smaller than 0 and y over x smaller than 0. This means when case smaller than 0, we have case minus 1 smaller than 0, case minus 2 smaller than 0. With any k values, when x and y have different signs, it means the product of two small negative numbers always greater than 0. The product of two negative numbers always greater than 0 again. Because this is negative numbers, something like negative 8 is positive number, this is negative b is positive number. We will eliminate two negative numbers here. here. Then this will become A multiplied by B. And then we know A and B are positive number. Then the product of A and B should be greater than 0. Obviously, the inequality always corrects with the situation x is positive number and y is the negative number, or x is negative number, or y is the positive number. So we have to check another case that x and y as positive numbers, or x and y is negative numbers. If x and y are positive numbers, then case always greater or equal than 2, because x over y greater than 0, same for y over x greater than 0, and this would be x over y plus y over x equal to square root of x over y plus square root of y over x square minus 2 minus square plus 2. Then obviously this always greater or equal than 2. It means case greater or equal than 2. The same method to prove case greater or equal than 2 with x and y are smaller than 0. Just the same method, because x over y greater than 0 and y over x greater than 0 as well. Then obviously in this case, case minus 1 greater than 0, because case greater than 2. Case minus 2 is greater or equal than 0, then case minus 1 multiplied by case minus 2 is greater or equal than 0. It means the inequality is always correct in this case as well. And the equality happens once x over y equal to y over x, and then x squared equal to y squared, because x and y have to be the same positive or negative number, then x have to be equal to y. Finally, we can prove this problem by this way. And the lesson from this problem is we have to check the condition when x greater than 0 or y smaller than 0. Same for x is negative number and y is positive number. And we can use these properties. And the most important thing is product of two negative numbers is positive number. So the rest of the case is the easy one, because it is the familiar form. We have to rule it many times before. So that's all. Thanks for watching. See you later. Bye.